Bismillahirrahmanirrahim. Now we are starting the part 2 of the lecture number 5, and I am starting a new topic, that is multiple integrals. In this topic we will mainly discuss that double integral and triple integral. How we will manage when we have double integration and how we will manage when we have triple integration. So starting with double integration. So we are working on evaluation of double integral. Once we have the idea of double integration, then it will become much more easier to deal with triple integration. So double integral over a region, let's say the region is denoted by A, may be evaluated by two successive integrations. Means if we have double integration, then we have to integrate one by one both the integrations. Let's say if A is denoted by f1x less or equal to f2x y and x is between A and B, then double integral over the region A fxy dx dy, or let's say here we say dA area over the region A is equal to A to B, y1 to y2 f of xy dy dx or dx dy. Means if we are integrating any region, let that region is denoted by A, then the function of two variables will be denoted by x and y, and we have to integrate with respect to x and with respect to y. Now the most important thing is that how we will evaluate that we need to differentiate with integrate with x first or with y first, or it is always same whether integrate with respect to x first or y first. So this is the most important thing to understand, and that is why I am now highlighting here. So there are two possibilities, so I am making these possibilities as first method and second method. So in first method, let's say we have a function f of xy, which need to differentiate with respect to x and with respect to y, then you need to integrate with respect to y first and then with respect to x. You need to integrate with respect to y first and with respect y first and then secondly with respect to x, because the limits of y are given. So I am writing it here as well. Function of xy, the given function of xy is first integrated with respect to y, treating x as a constant between the limits y1 and y2 as written here, and then the result is integrated with respect to x between the limits a and b, which is given here. So this is the one method, that integrate with respect to y first and then the obtained result will be integrated with respect to x. Now there is a second method as well. So I am highlighting the second method here. In second method, if we need to integrate the function, then we integrate with respect to x first and then with respect to y. Here fxy will be integrated with respect to x first, treating y as constant between the limits x1 and x2. Then the result will be integrated with respect to y between the limits c and d. So what we are saying, that either you have to integrate with respect to y first and then with respect to x, or in secondly with respect to x first or and with respect to y second. Now, the most importantly, I am mentioning this here as a note that for constant limits, it does not matter whether we first integrate with respect to x and then with respect to y, or vice versa. So it means the most important thing is that to understand that how we will evaluate that which integration will be performed first and which integration will be performed second. The first important point is to see the limits. If both limits are constants, then it doesn't matter you integrate with respect to x first or with respect to y first. But if the limits are not in constant form, then we have to decide with respect to given limits. So now I am highlighting few examples to show you that how we will evaluate this criteria. So here are few examples. Number 1, 0 to 1, 0 to x e power y upon x dx dy. This is one example. Another example is 0 to 1, 0 to under root 1 plus x square, and then we have dx dy over 1 plus x square plus y square. And then another example, xy dx dy over the region in the positive quadrant for which x plus y is less or equal to 1. So now I write down 3 examples to show you that how we will evaluate this one. Now look at these limits. These two limits are constants. This limit is constant, but this limit is a variable. Here the same criteria, these 3 limits are constant and this limit has a variable. So if we have a variable in the limit, then you must identify that which variable is given here. So if the variable is given is x, then it simply means that you have to integrate with respect to y first, because these limits are in x. So here and here we need to integrate with respect to y first. and then with respect to x. If we have the limits with respect to y, let's say I write it here as 1 plus y square, then it means now I need to integrate with respect to x first. So if the limits are in y, then you need to integrate with respect to x first, and if the limits are using the variable x, then it means you need to integrate y first. But if limits are in such a way that you do not know that which thing is where, then we need to draw the figure and then we will decide. So solving first these examples, so it means 0 to 1, I am integrating here e power y over x dy. I need to integrate with respect to y first. So what will happen? 0 to 1, so e power y over x is y over x, and treating x as a constant, so now 0 to x and dx. So it means now we have 0 to 1 x into e power y over x 0 to x dx. So now we will substitute the limits. So if I substitute the limit, it will 0 to 1 x into e power x upon x1, so x into e minus x into e power 0. Upper limit minus lower limit. Upper limit was x, so x upon x1 and then x. So now I am solving here now. So it means now we have 0 to 1 x into e minus e power 0 is 1x dx. So now integrating, so it is x square by 2 into e minus x square by 2, and limits are 0 to 1. So if I substitute here, it will be 1 by 2 e minus 0 minus 1 by 2 minus 0. So it means 1 by 2 e minus 1 by 2, or if I take 1 by 2 common, e minus 1. So this is the way if we have the limit in terms of x. So now conversely, if I have the limits with respect to y first, then what will happen? So let's see, now we have example number 2. So it is 0 to 1, then 0 to under root 1 plus y square, and then we have 1 upon 1 plus x square plus y square dx, and then dy. If you compare this one, I integrated with respect to y first. Y, the limits are in x. If the limits are in y, you need to integrate with respect to x first. So it means if I am integrating with respect to y first, then what will happen? This will be 1 upon plus y square tangent inverse x upon 1 plus 1 upon 1 plus y square tangent inverse y upon 1 plus y square. This is, I am applying the formula. This is 0 to under root 1 plus y square dy. Because how I am treating this, so this is 1 upon, this is, if I write it in this form, so this is constant and this is variable. So applying the formula 1 upon 1 plus x square, this is what I am applying the formula. So if I show you that 1 upon a square plus x square dx is all equal to 1 upon a tangent inverse x over a tangent inverse x. So now we integrated with respect to x, and now it's time to substitute the limits. So this is constant. So now applying limits, tangent inverse under root 1 plus y square upon 1 plus y square minus tangent inverse 0 dy, because we are substituting the limit with respect to y first. So now I am writing here, so you have all the steps in front of you, 0 to 1, 1 upon under root 1 plus y square. Then it means we have tangent inverse 1 upon under root 1 plus y square, and tangent inverse 0 is 0. No, tangent inverse 0 tangent inverse 0 is 0, and then we have dy. So now what will happen when we have this kind of result? Now we need to integrate this thing and we need to apply the u into v result.